when we worked with linear equations, we learned to solve linear equations. We learned to do one-step equations and then learn how to solve two-step and then multi-step. And we've done the same thing with inequalities. We've learned how to solve one-step inequalities and two-step inequalities and multi-step inequalities. So now what we're going to do, just like in equations, we're going to learn how to graph them. Okay? And just like before, it's very similar to graphing linear equations. Graphing linear inequalities, very, very similar to graphing linear equations. So our goal today is we want to learn how to graph them on a coordinate plane. We're still in the same Common Core set, okay? So the same ones that we've been working with. You do have some new vocabulary. Boundary, half plane, and then we have a closed half plane and an open half plane. Now, these should sound a little familiar to you when we talk about closed and open. When we would graph inequalities on a number line, we had closed circles and open circles. So we'll talk more about that as they come up. Okay, in order to graph a linear inequality, okay, we want to first graph the inequality using a line, then use a test point to determine which half plane is going to be our solution, and then we're going to shade it. Okay, let's show you how to do that. Okay, if we wanted to graph 2y minus 4x is greater than 6, what we first have to do, just like we did with linear equations, we have to put this in slope-intercept form. So what we need to do, we need to take this and we need to solve for y. Okay? So we will add 4x, we're going to bring the 4x over, then we need to divide by 2, and we get y is greater than 2x plus 3. When we go to graph this, we're just going to graph it like it would be y equals 2x plus 3. Okay? So let's graph that equation. All right. Y equals 2x plus 3. Again, we're kind of treating it like a linear equation. So if you remember how to graph linear equations, here's your y-intercept. So we're going to go to 3 on the y-intercept, on the y-axis, 1, 2, 3, and there's our first point. Okay? Our slope is 2, or 2 over 1, so we're going to rise 2, 1, 2, and over 1. Here's our second point. Or you can go down 2 over 1 this way. Okay, and there's going to be our line. However, we have to be careful. This is one of the differences with graphing linear inequalities. You can see that it's a dotted line. And this is your first vocabulary word. This is your boundary. Okay, this is your boundary. This line is your boundary. And it's dotted because if you look at our inequality sign, it's just greater than. It's not equal to. So this is it's going to be a dotted line because, again, your solution is not equal to 2x plus 3. It's only greater than. If this had a equal to sign underneath it, then it would be a solid line. So there's kind of your first difference, sort of like with the open and closed circles on a number line. You have to be careful with that. Okay, now what we have to do, that's not your answer. Okay, we actually haven't graphed a solution set to this. We've just graphed the boundary. We know that what this is saying is everything, your y has to be greater than 2x plus 3. So the easiest way to determine what your half plane is going to be, and you'll see what I mean by half plane here in a second, we have to use a test point. And the easiest test point to use is 0, 0. Okay? 0, 0 is your origin. So what needs to happen is we need to plug 0, 0 into our inequality up here. So if we plug 0, 0 in, we plug our y in for, our 0 in for y and 0 in for x, and we simplify, we get 0 is greater than 3. Well, that's false. So what that's saying is 0, 0 is not a solution to our set. So your half plane then is going to be, your half plane is going to be shaded above. Okay, see how this is shaded? Because 0, 0 is not in the solution set, any of this below the line or less than the line is not a solution. However, everything greater than this boundary line is going to be your solution. So you're actually shading. You're going to shade above or greater than this boundary line. 0, 0 was not in the solution set, so you know that anything underneath this line cannot be part of the solution. However, everything above it is going to be. Okay? Let's try a practice problem here. The first thing, again, you should do, you have y minus 3x is less than 2. The first thing you should do is go ahead and change it to slope-intercept. Okay? So if we change this to slope-intercept, we get y is less than 3x plus 2. Okay? So go ahead and graph that part on your outline. Go ahead and pause the video. Okay, so if you go to graph that, first of all, when you go to graph your line, it's not equal to. So your boundary line is going to be a dotted line. Okay, so let's take a look. Your first point was at a 2, so right here. Then your slope, 3 over 1, so you're going to go up 3, 1, 2, 3, over 1, or you could go down 3 and over 1 this way. When you go to draw your line, again, it's going to be dotted because it's not equal to. So let's choose the point then, 0, 0, to determine if that point, if that origin, that point is in our solution set or not. Well, if we plug 0 in for y and 0 in for x, we end up with the inequality 0 is less than 2. Well, 0 is less than 2, and that's a yes. So 0, 0 is in our solution set. So you're going to shade everything that is less than or below that boundary line. Okay? Everything that is less than or below that boundary line, because that 0, 0 is part of your solution, because this statement was true. Okay? Let's look at another example. Okay? Now you can look and you can see that, well, now our sign has changed. It's now equal to. But we still do it the same way. We still have to put it in slope-intercept form, so we're going to solve for y. Okay. When we do that, we need to subtract our x, then divide by 4. So here now is our inequality written in slope-intercept form. Okay. So our first point is going to be at 1/2. Then what we're going to do is we're going to go down 1 and over 4 from that point. Okay. So here's our line. Now notice this time that your line is solid. Okay, it's a solid line because it's equal to that. Okay, so again, we're at 1/2, and we're going to go down 1 over 4. 1, 2, 3, 4. Here's our point. Or we can go up 1 and over 4. 1, 2, 3, 4. So after you graph your line and it's solid, pick the test point again, 0, 0. Now they use 2 and 2. You can pick any point you want to. I suggest using 0, 0 only because it's easy. It makes things easier to simplify. Okay, but they chose 2, 2. So when you plug 2 and 2 in, you get 10 is greater than or equal to 2. That is a true statement. So what that means is 2, 2 is part of that solution in that half plane. So the half plane that you're going to shade is the one above it or greater than the line, everything above the line. Okay? So really the only new part that we're looking at is some vocabulary, our boundary line, whether it's a closed half plane like this one or an open half plane. And we call it half plane because it's half of the plane. You're shading half of the plane. Okay? All right, go ahead and pause the video and try this one on your own. Okay, let's see how you did. Okay, first thing you had to do was change it to slope-intercept form. All right, so if we subtract x, then divide through by 2, you should get y is greater than or equal to 3 minus 1/2 x. So again, your first point is at 3, which is right here. Then we're going to go down 1 over 2. Down 1 over 2. Or you can go up 1 and over 2, this way. And it's going to be a closed boundary line. And if we use the test point 0, 0 If we plug in, we get 0 is greater than or equal to 3. So we're testing this point right here. Is 0 greater or equal to 3? No. So since that's false, 0, 0 is not part of your solution set. It's not going to be in this half plane. So your answer is, again, it's greater than anything above that line is going to be shaded. Okay? All right, one more example here. This time we're going to use a graph. They're going to give us a graph, and they want us to solve this inequality, 2x plus 3 is less than or equal to 7. They want us to solve it by just looking at the graph. Okay? So let's take a look. It says, first graph the boundary. Okay, so what we want to do, let's go ahead and solve for x, and we have x equals 2. Okay, we're just going to replace that sign with an equal sign. So when you graph x equals 2, okay, we're going to make our line, our solid line here. And if we go back and we plug in our test point, 0, 0, it gives us 3 is less than or equal to 7. Well, that's a true statement, right? 3 is less than or equal to 7. So what side do you think we're going to shade on? If this is a point in our solution because that's true, looks like I bet we're going to shade over here. Yep. So our solution to the set is x is less than or equal to 2. Since it's less than, we're shading everything this way of that boundary line. Okay? Now your example, it's already graphed for you. Okay? They want to know if you're given this inequality right here, and this is the graph to it. Can you write an inequality statement using this to show what your solution is? Well, it's at 1, 2, 3, 4. So you know 4 is going to be in your solution. We've got a dotted line or an open half plane here. And it looks like anything greater than 4. So your solution is going to be x is greater than 4. Okay, it's not going to be equal to because we've got an open boundary line here. But this way, going this way, is greater as everything, all of our solutions greater than 4. Okay? So that's pretty much graphing inequalities. We're going to do it a lot like we did when we graphed linear equations. We just have to be careful of solid or dotted lines, and we need to figure out, are we graphing above the boundary line, are we graphing the half plane above it, or are we graphing the half plane below it? All right, so finish your outline. We will come in tomorrow and answer questions and check your answers. Okay?